Okay. Yeah, so we can wait like for a few more minutes and see if anybody pops up.
Yeah, sounds good.
Otherwise, we made it. So
Yeah.
mm.
Um,
You know
uh,
what? Actually, I can show you like what we got. So
yeah,
in
that would
this
be great
case,
actually.
we just
I'm very curious to see because I know because y'all were using what is the
BirdNet.
yeah, BirdNet, right? And is that so the is the Cornell Merlin app built off of okay, that's what I
Yeah,
thought. Yeah,
yes, right. So the BirdNet is the base, and that Merlin is like on top.
right.
Yeah. So like, in our case, we are building up the like going to build up the model, which is going to identify only Humes. So and the
Right.
approach could be quite the same as the BirdNet
Gotcha.
because like yeah, I've read like a lot of papers like how they build up the all the stuff. So it could be kind of the same, but only for one bird. Yeah.
Right.
Let me share the screen. I'm gonna show you. Okay, so like just that's the notebook, like some
Hmm.
functions. So basically, yeah, uh, I'll just show you the plots. So like that, so we got almost 200K of the all observations, and
Yeah.
like point 0.5, zero point 0.6, zero point 0.7 till zero point 0.9 is the confidence level or the probabilities. Let's say
Right.
like zero point 0.5, that's the probability we identify specific class. So and mm, the green line is the line for the observations for of the birds that are in the list Pranav gave us. So like he told us, okay, that's the
Gotcha.
list of all the birds that are specific to this area.
Right. Right. Birds you
So
would expect to see in the
in this area, yes.
right.
And the blue one is like non-habitant. So like
Hmm.
like some misclassifying or like some it is the misclassification in any
Right.
case. Yep. So, and like just some numbers, like some plots, and actually right here, that's the decision-making plot where we can see. So like the red line, it
Hmm.
is the accuracy across confidence levels, but in fact, it is um, mean average, like for the all confidences level. So let's
Gotcha.
say at zero point 0.5 the average for all confidence level it's like around like 70.76, and at the same time on the share of habitants is like a little bit higher and like around like 80, 81, 82, and like around 19 for non-habitants, and we can
Hmm.
see like the average confidence level at zero point 0.7, it's almost the same as for the habitants, and we are
Right.
classifying habitants, so like we decided like put the trade-off at zero point 0.7 confidence level. So like the accuracy at confidence level is 0.866, and at the same time the share of evidence it is 0.86. So that's the point where we um, doing our analysis. Yeah, like yeah. So like we
Gotcha.
started to do the analysis, like doing all the stuff. So I'm sorry. So and this is yeah. So we got total number of observations, a little bit more than 100K, 34 birds, where we have four birds making up almost 80% of all the observations. So there's the
Wow.
western crowned warbler, Humes, um, I don't know, like variegated and greenish warbler. So like,
Yeah.
and the western crowned warbler is 41%, followed by the Humes, like 19, almost 20. So like, and we noticed this that most observations happened in June between 5 and 7 a.m. at the low elevations from 320 to 316, 360,
Hmm.
3,600 feet, and this is the longitude and latitude. So like it's basically within like within miles and 0.4 miles. So it's just small area,
Yeah.
like very small. So and like just yeah, like doing all this stuff. Yeah. So that's for the Humes only. Uh, so like as like all the observation is basically at low elevations. For the Humes, it's a little bit different. It's more
Hmm.
at mid elevations, and it's like almost like half of that happened at mid elevation. And actually, it's a little bit late early bird. So like
Right.
the peak is between 6 and 7, slightly fewer observations at 5 a.m. And this is also like the observations like starting at 3,400 till to 3,600 feet, and
Mhm.
the same. So like same like it's even the area. It's even like more like like some smaller than for
Yeah.
the total range. So let's be also like okay some reports. Let me see. Oh yeah, that's so like yeah. So we also that snippet. Okay, let me see 1 second. Oh yeah. So like we also trying to catch the duration of the songs. Let's say
Right.
like so like every chunk it is 3 seconds. And we were trying to see like the continuous uh duration of the song. Let's say like more
Hmm.
than 3 seconds, like just one by one. So and in this case we got 15K observations with more than 3 seconds songs. So and the average duration of the continuous song is about 9 seconds. And actually, it was like a quite interesting fact that Western Crowned Warbler was the champion, right? And so,
Hmm.
and specifically at one place, like it calls PSL 10, so it's like
Yeah.
low elevation. He sang like almost 9% of all the birds' observations. So
Wow.
presumably it's one bird, like
Yeah.
love to sing. So like, and the bird got 7 instances from 100 second to 210. So like few minutes, just nonstop.
That's
It's
crazy.
it is crazy. I mean, can you imagine like yeah. So as to the Humes, uh, he was observed like 2,700 times, or like almost like 18% of total observations, like
Hmm.
overall in general. And the average continuous sound is a little bit less than the total average overall. And he sang like 6 seconds for 64% of his songs, and the maximum duration was 69 seconds. So um, comparing with the Crowned Wolver, he's just he doesn't. He's like he's a man of a few words. Yeah. Yeah, so the elevation is the same like it is a mid elevation, not the low
Right.
elevation. Yeah. So like, this is code for like who's singing 3 seconds before and after Hume's Wolver. But I just found out probably the code is a little bit it's not catching the right information. So I have to
Mm.
like think to recode. So I'll just
Okay.
um yeah, also like we also trying to oh yeah, so we also try to catch up. Sometimes, like within 3 second chunk, you can catch a few birds
Right.
singing together. And like in this case, uh, I didn't write yet. So let me see. Yeah, that's like the pairs of the birds singing together. So the Humes, like let me see. 1 second. We got how many? So yeah, we got like 1,300 observations and almost 25 percent. Uh, it is the pair of Humes and Himalayan bluetail. So
Mm.
that's the pairs of those pair of the birds who were singing like at the same time
Right.
within 3 seconds. And also yeah, and this is pairs only for the Humes.
Mm.
So the blue tail, greenish warbler, and actually quite unexpected. Um, Western Crown and Hume's met only 11 times,
Yeah.
despite like uh, this guy loves to sing. So,
Right.
but probably it's not unexpected because like he loves to sing at the at the low elevations, and
Right.
Hume's it's more like about the mid elevations. That's probably the main point because like the elevations and the areas are a little bit different. Yeah. So and I still have to write down some summaries and redo my code for the 3 seconds before and after Hume's Warbler. So like the main point for this code, 3 seconds before and after, it is a kind of a communication. Let's say like me being like a bird, I'm singing, and then like within 3 seconds, Hume's start to interact, like
Right.
protecting the area or doing anything else. So just trying to catch like, okay, so who's singing after Hume's and before. That's it. But the code is not really right, and I have to like mm, redo it. Yeah, that's pretty much we got it, and that's like for the whole situation in this area. And also, I'm gonna share like the maps, like last
Yeah.
time. Yeah, like I've done it, but I have to connect. So like I haven't done that yet. So like I have to connect the see like the nest and the elevation and the mics. So like let's say
Right.
let me so yeah like yeah blue is like the mics outermost and the red is like nest locations and PSL 10 actually let me find it out. PSL 10 is the champion.
Oh
PSL
yeah, I
10
see it. I think it's just to your right.
to my right. Oh yeah, it's right here.
Yeah.
Yeah. So actually, like you see, like a lot of nests, and
Yeah.
this distance, it's around maybe like 500 feet, like average, like 500 feet, maybe like just like I mean like 1 inch. I
Hmm.
guess like yeah, it's like a little bit. It is a half of inch. Yeah, it's like about 500 feet, like in real
Right.
world. Yeah, so we have a lot of nests right here, and this is all for the Humes. So probably somewhere here we not probably we have that Warbler.
Yeah.
What is that like? Yeah, I don't know. Like yeah, so yeah and this is like I just want to connect the location and the um, outcomes from the code. Yeah.
Yeah. No, definitely. I mean, these are some very they're very well thought out graphics, and I think they show a lot of like good information.
Yeah, absolutely. So like, and I also have to plot some charts because like
Yeah.
like it's just numbers, and in my case, I have to do like some visuals. So we
Mhm.
we can put them on the paper. So I just thinking like, what will be the best visual for specific information. Yeah.
Right.
So that's what we've done so far. And we a little bit struggled with the data set itself, but
Yeah. Yeah. I was gonna ask. So like, what is the so you I know you were talking about like 3 second chunks. Like what format is the data? Is the like does the audio come in like straight from the microphone?
WAV.
And how like are the clips are they like variable length? Are all the
No,
like audio
actually,
clips the same length?
so it is like 15 minutes
Okay,
recording.
gotcha.
So, and basically you analyzing the 15 minutes recording and
Mhm.
split it into 3 second chunks. And then like within all these 3 second chunks, you're trying to classify any bird
Right.
that is like within this chunk. So like and let's say like at 4 a.m. I guess like 0.5% of all the birds singing at 4 a.m.
Yeah.
So yeah, someone is singing
Yeah.
like 4.5. Actually, it will be interesting to find out who's the song. I mean, like who's the bird?
Right.
Yeah, and basically 5, 6, 7 a.m. Like I will say probably 70%. Oh, I'm sorry, not 70, like about 90% of all the birds are in between 5 and 7 a.m.
Yeah. I mean, I know like I know I've read this is probably a long time ago, but like one of the reasons I read that like birds are more active in the morning is that because the air is colder, it's more dense and the sound can travel farther through denser air. And
Interesting.
that would I now, don't quote me on that. I heard that was probably a long time ago that I heard that. But I remember
Well,
that. I mean, I'm kind of an early riser myself, and I definitely feel like 5:30, 6 in the morning, the birds are way more active than eight. You get into like 7:30, 8 a.m. Things are a lot quieter.
interesting. I mean, like density helps you to like enhance your like audio waves. Interesting. Wow. I mean, I didn't know about it, but I mean, it looks quite reasonable at some point. Yeah, and interesting. Yeah. I mean,
That was just a fun little tidbit I thought maybe.
no, no, it's really cool. It's really cool. Yeah, I mean,
So
yeah. So like you have to explain, like let's say like yeah, because four, I guess that's it's about the sunrise. So like basically
yeah.
the sunrise is around 5, so that's why the 4 a.m. is like a little bit too early. 5, 6, 7, probably yeah, like density of the air after 7, like it is less. Interesting, interesting. I haven't thought about it, to be honest. Wow.
So there you go. Yeah. I
Okay.
well, I wish I had
Oh,
some of our stuff to share. Unfortunately, I think Kashiga has like a whole thing that's like the video with the bounding box tracking the bird, and then
yeah.
you can see it shows kind of where the the model is missing the bird as it goes through the frame. I don't have the video readily available though, but we're just kind of we're still kind of working on getting things set up with these transformers with a temporal element going.
Hmm.
So I think it will be interesting to see too the difference between um like the vision like just the base vision transformer and the because I wonder sometimes how much like how many different encodings these models can really take before maybe the like the embeddings of the time, the position in the image, the image patch. Like I feel like you start building up so many embeddings in these transformer models. I start to wonder how much of that can actually drown out the underlying data. But I think we won't know until we get a little bit deeper into stuff. But
Yeah, yeah, yeah. So I mean, then, do you guys use Georgia Tech's facilities like Pace, or like you run all like everything on your laptops?
just for the time being, because we're still Oh, it's just been Andre and I. I don't know that it seems like no one else is joining. We've just been chatting though. So,
All right, yeah, no, sorry. I just wanted to make sure I didn't miss him because he was at he was at a meeting earlier, and I just wanted to make sure that he wasn't here and I wasn't. So,
Okay.
all good.
all right.
Yeah, no, we've just been talking amongst ourselves.
Well, I won't keep you. I'll just be a fly on the wall just so I know how both y'all projects is going. But yeah, you
Sounds
guys
good.
have at it.
Thanks.
Okay, thank you.
Um, I don't remember what was I
You were you
talking?
you were talking about the embeddings and the
Oh, that's right. Yeah, right now we've just been running things locally while we're trying to formulate like just kind of get some like a proof of concept together first before we start really, you know, requiring a lot more computational power. I
yes.
do think we're moving. I do think like with some of these models that require video, we are going to have to start like prototyping on some of the pace, like compute, just because the models are getting much larger
Yeah.
and they're requiring a lot more data to produce any sort of reasonable result than like it's just not something that you can do on a laptop.
Absolutely, absolutely. And in your case, what will be the success? Like, I mean, like I said, like, because I mean, fortunately, we have only one bird, right, in
Yeah.
the nest. So like, what will be the success? Like, what will be the final outcome for you?
I think like our goal outcome right now is, being able to accurately track the bird with a bounding box through a full video.
Okay.
I think right now our best results are very spotty because I mean I can show you. I'll share my screen quickly. Um, so I mean the bird mainly because the nest. I mean I don't know if you can see it, but I mean I can't see it. It's very difficult to see, but the actual nest is just a little hole in the ground right there.
Yeah, yeah, I can see it. Yes.
And the bird, I mean, in pretty much every video from this nesting site, and that's the other thing too, is we've only been working with one nesting site just to try to get, you know, something reasonable together first. Um, but the bird pretty much always shows up in this quadrant or
Okay.
like right in this zone.
Yep. Yep.
And the model is pretty good at picking up the bird when it's in this area, but there are other videos where there are two birds and one might be on this branch while the other one's down by the nest, or sometimes they appear a little bit deeper in the background. Those I think when it's kind of in the background like up here, we're less interested in. I think we're mostly interested in when it's kind of in the foreground
Yep.
because most of the camera traps are set up very close to the entrance of the nest where it's clear what the bird is.
Hmm.
So but I mean, I'll open up another one. I mean, yeah, you can see it's right in the same area. I
Hmm.
think this I
Hmm.
think this video might be the one with two birds. Um, but anyway, yeah. I mean, and these are manual annotations that I did. These are videos for training and validation. Um, but I mean, yeah, that's pretty much what's up, you know. I'm just trying to get um the transformer models in working order.
Yeah.
Well,
I
and
mean,
it's we've got such a limited time too. We're coming up towards the end of our stint. So
yeah. Interesting.
yeah.
I hope like you just the model you're running right now
I'm
gonna
sorry.
help you. I mean, I just hope the model you found like right now
Yeah.
is like could solve the problem. Yeah.
Yeah, I hope so. I hope so too.
Yeah, at least just now capturing. Yeah, I mean, it's interesting. It's interesting because Transformers. Uh,
I mean,
I
I
just
think I
know.
think
Yeah.
go ahead.
No, I mean, I know just a little bit about the computer vision. I mean, I know like the just general information, but I haven't even like got the course. But I'm thinking of getting it. So
Yeah, well, I mean, I think this work specifically is very interesting for me because I'm in the computer vision class right now, and I'm also in the deep learning class. Right.
okay.
So I'm learning a lot of like the classical computer vision techniques, which are they're very interesting. They're not super applicable here because like making a template of the bird and then using some sort of like template matching or, traditional tracking methods just isn't really all that feasible, I think, when you're talking about when you're going to look at like the broader scope and all the different nesting sites. It just doesn't seem that realistic. And then now with, with deep learning, these transformer, like the transformer based vision models are very much the hotness right now. So,
Yeah, yeah, yeah.
I think it's been very interesting to kind of be in the classes about this research into these topics, and then be doing this is very interesting. But I think no matter whether we end up with good results or not, I think we'll have some interesting things to say, specifically about like recognizing objects that are well camouflaged in video,
Oh yes.
because I mean, some of these videos, like going through and annotating them, I there's no way I'd be able to see the bird unless I am like flipping back and forth between two frames where it moves. I mean,
Wow.
it really is just like blending. It blends in so well, and which I guess is the goal for the bird. But
How do you define the camouflaging? Like, okay, so in this case, I guess you have to set up the parameters of colors having like similarity, right?
Mhm.
So have you ever thought of it? I mean, just like like setting up the any parameters. I mean, if it's applicable to the computer vision task, because I mean, if it's like if the bird was like let's say red and blue, it will be easier. But in
Right.
this case, like when the bird is like yellowish greenish, so then just it is a camouflaging, but the parameters could help you as well because still there is a difference.
Yeah, I mean, I think there definitely is a difference between, the color of the bird in the background. Um, but like, I mean, I don't know. When I think of techniques to kind of sharpen that difference, I mean, I think about maybe projecting it into a different color space, but I think that the color of the bird in the background would be too similar to project it. Like you'd be projecting it into a color space that sharpens both the bird and and the foliage in the background, right? Which ultimately isn't that helpful. But um I like where I see the biggest advantages with the difference image between frame T and frame T plus one, subtracting the I mean, especially in a location like the one where I showed you, where the background doesn't move that all that
Yeah,
often. I think that difference image is, and like the temporal element is going to be the most helpful. Um, so we'll see.
yeah. I'm just thinking like this. I mean, I'm not sure if the approach could be right. So let's say the camera
Mhm.
it's always on the same spot. And
Right.
basically, like in your case, so it is the summertime. So the colors are not changing that much. So basically, is it? I'm not sure. Like, is it possible? Let's say like um decode like not decode encode like those colors in different colors. Let's say like for all static objects we can make, let's say, not green, but yellow, red. So like all the colors on the image which are static could be different colors, and anything that is like coming like outside of the static image, it's just gotta be like same colors.
Yeah, I mean, there are all different kinds of background removal techniques
Yes.
that, over the course of, 3 to 20 frames, it'll build a model of what the background is, and it'll just delete it and make it black.
Yeah,
And
yeah,
then
kind of.
anything
Yes,
that's
right.
moving
Like,
then becomes, um, yeah, I mean, I definitely, that's definitely something we've thought about, like using some of those classical like CV techniques.
yeah,
Um, it's not something we've tried to implement yet, but it is definitely an addition, like an area that we're looking at. Um, yeah, I mean, it's not something. It's yeah. I mean, it's something we probably will explore as things get. I mean, I don't know. We'll see.
no, yeah, absolutely. Because I mean, like, if you make the background like black, I mean, yeah, absolutely.
Yeah.
So like, it will help you to actually identify anything coming outside, like anything. So like in this case, just like it is static always. It is, and it's not like crossroads, so it's like a little bit different. Probably it is worth to explore it at some point, but I have no idea. I mean, just like it's a very uh subjective. I mean, I have no idea.
Yeah. I think for this specific site, I think that the background removal has a great potential to be, very successful. I think there are instances where I'd be scared to rely on background removal too much just because of things like rain and wind, then like especially when in dense foliage create a lot of movement,
Okay.
which I think may present problems for like the deep learning, for the transformer
Mm-hmm.
model as well.
Yeah, yeah,
But
absolutely, yes.
um, you know, I think these are all I think they're all great questions, and they present like a lot of different problems, but also opportunities.
Always, always.
Yeah.
Um, Actually, yes, we like here like for almost 40 minutes. Wow.
Yeah.
Yeah, but anyway, let me know like yeah, I haven't gotten that course yet, so I can't
Yeah.
really help you.
Are you thinking
Yeah.
about taking the computer vision class?
I am, because I mean like it is a part of machine learning
Hmm.
specialization, and it's always good to know like how do you mm, do all this computer vision stuff, especially like now it is a must. It is a must
Yeah.
because it is a must. That's it.
It's
Nothing to
I
add.
I've been enjoying the computer vision class so far. Um, I think there's some changes that could be made to maybe make it a little bit better, but it's been good overall. I definitely think there are some it gets early on, it's very much in the weeds of like the geometry of photography and like how cameras work, and which is, I mean, it's very interesting, and some of the stuff that like some of the projects you get to do are very interesting, but some of the lectures can be a little bit of a slog to get through.
I get it.
But
I get
but
it. Yeah.
overall, it's been good.
Perfect then. Yes.
So,
Um,
all right. Well, unfortunately, I think I
yep.
gotta get back to it. But
Me too. Yeah.
yeah. All right. Sounds good. Well,
Okay.
I mean, it was great. I was great to hear about your project and kind of just chat generally.
Same here. And anything, just let me know. Hit me, and I'll
Yeah,
try to help you out. But
will
yeah,
do.
see you in 2 weeks then.
Sounds good. See ya.
Okay. Okay. See you.
Bye.
Bye bye.